Welcome back, guys. I hope all of you will be fine. So this is question 5.14, and the statement of it is the percentage of wins for the Chicago Bulls basketball going into the playoffs for the 1996-97 season was 87.7. Okay, so this is the probability of winning. Round the 87.7 to 90 in order to use table A.1, which is given in your book. And as we are not going to use the table A.1, but let us assume that we have been rounding it from 87.7 to 90, so that's why probability here would be 0.9. So therefore the probability of losing would be q, which is what, which is 1 minus p, and p is 0.9, so 1 minus 0.9 is 0.1. Okay, so on the basis of this data, what do we have to do? We have to find the answers of some parts of it. So part A of this question is, what is the probability that the Bulls sweep 4-0 the initial best of 7 playoff series? Okay, so initially this sweep means the Bulls has to do what? It will play 4 games, and out of those 4 games it has to win all of those 4 games. Okay, so therefore again this is the problem of the binomial probability law, and I have to find the probability that k equal to 4, and this is 1. The formula of it is n choose k p k q n minus k. Okay, let me put all these values here. So n is 4, k is 4, okay, according to this here, and p is 0.9, 0.9 raised to power 4, and 0.1. 4 minus 4 is 0. Okay, so here what would we get? Here it would be 4 factorial divided by 4 factorial into 0 factorial, because 4 minus 4 is 0. Here it would be 0.9 raised to power 4, 0.1, it would be 1. Okay, multiplying all those terms, these will be cancelled out, and finding the 0.9 raised to power 4, what would I get? Here answer of it would be 0.6561. Okay, and that is what, that is the solution of part A of my question. Okay, now in part B, what is the probability that the Bulls win the initial best of 7 playoff series? So winning the playoff series means that it is playing best of 7, and in best of 7 it will win the series if the winning is greater or equal to 4, means all the values of 4, 5, 6, 7, it means winning the series. So therefore what do we have to find out? We have to find the probability that k is greater or equal to 4, which is what, which is probability that k is equal to 4 plus probability that k is equal to 5 plus probability that k is equal to 6 and plus probability that k is equal to 7. Or we can also write it like from k equal to 4 up to 7, we have to find all the probabilities that k is equal to small k. This is, let me have here, this is small k, or as this is what, this is the problem of the binomial probability, so that's why writing it like this one, k is equal to 4 up to 7, here writing the formula for the binomial probability law, which is n choose k. Okay, p is k and q is n minus k. Let me write all these values here. Here it would be k equal to 4 up to 7. Okay, the value of n is now what? This is now 7, because the games here are basically 7 games, which has been written here as well. And all the values of k would be from 4 to 7, because this is the winning, and we have been leaving it here because putting them all together and then adding them all will give us the answers. And here the probability of it is, or the probability of winning is 0.9, which is the same as mentioned here. So 0.9 raised to power k, and q is what? Q is 1 minus p. So 1 minus p is how much? That is 0.1. So 0.1, and here 7 minus k, which is n minus k, okay, given here as well. Now after finding all these values and adding them together, which you can do very easily, the answer of it would be what? The answer of it will be 0.9973. Okay, so that is what, that is the answer of part B of my question. Part C is what very important assumption is made in an answering parts A and B, and that is the only assumption which is already given in the statement is, and that is the rounding of the winning from 87.7 to 90%, and that is the probability that is 0.9. Okay, so this assumption has been made, which is common in all of them. You can see that it is already given here that the probability of winning is 0.9. Here it is also 0.9. So this is the only assumption which has been made. So that's it for today, in which we have seen the solution of question 5.14. So see you soon.